Hello, everybody. This is Group M1 with a short presentation on the cutting edge of technology and manufacturing with a special focus on big data, the Internet of Things, and virtual reality. So a quick introduction to advanced manufacturing. Um, we're going to be keeping our focus on three new emerging techniques used in the industry. The first of which being big data, which is the translation of large amounts of raw data into usable information. Secondly, we'll be looking at the Internet of Things, which is a programmed system of objects that have the capability of sharing data, information, and assets by themselves. Our third topic is going to be virtual reality, which is the specialized use of computer interfaces to immerse the user into simulated environments using visual aids. And now all three of these technologies can be interconnected in the industry to help increase efficiency and productivity, but we'll be taking a quick look at them individually. So an introduction to big data. Data is the most raw form of information, and processing all this information has become a difficult task in the modern day. This is because of the recent explosion of the level of data on the internet. So for a quick example, in 2007, there were approximately 280 exabytes of data on the internet. And by 2017, this number had jumped to 15 zettabytes. And keeping in mind that one zettabyte is a million exabytes, you can see this is substantial growth. And this has led to an expanding market for analytical tools that are capable of extrapolating useful information from this otherwise unscalable mountain of data. So some current applications of software to analyze big data would be supply chain analysis, quality control, and customer service. So a quick look at supply chain. The supply chain encompasses every step of the manufacturing process from acquiring raw materials to their eventual sale to retailers and customers. And at every step in this process, in this chain, there are inherent losses and expenditures. And by analyzing the data from these expenditures, companies are able to locate and minimize these expenditures and remove value degrading processes from the supply chain. And in quality control is used inside of the manufacturing plant and takes quantifiable data from the equipment inside the factory to actually predict when and where defects are going to occur and why they are occurring. This allows for replacements to occur before failure or the level of defects starts to cut into the bottom line for manufacturing companies. And for customer service, uh, by analyzing different customer trends and spending habits, manufacturers are able to create effective marketing strategies that allow them to push their products effectively.
This brings us to the implications of virtual reality or VR in manufacturing. But at first, let's get an idea about what virtual reality is. Virtual reality is a computer interface that is capable of immersing the user within a simulated perception of an environment or situation with the help of visual and audio aiding technologies. It helps to enhance the interaction between computer and human participants. At present times, human beings have used virtual reality for various purposes, including entertainment, pilot training through flight simulation, depression therapy, education, communication, etc. One of the exciting prospects of virtual reality is its implication in manufacturing and prototyping. So probably you're wondering how VR can be integrated in manufacturing. The answer to your question is VR at recent times has been successfully integrated in almost all aspects of manufacturing, including design, operational management, machining, and assembly. Virtual reality can be used to a great extent for product designing and prototyping. Applications of virtual reality for product designing can allow the designer to effectively evaluate the design, find alternative design solutions, error in the design virtually, which can save a lot of money. Virtual reality applications in operations management through augmented reality systems to simulate any manufacturing environment for planning, simulation, and training of individuals involved in the operations. It can increase workplace safety. Virtual machining or VM can also be performed using VR. As you can see from the photo, how a user can use VM interface to evaluate factors of machining through VR, which can save a lot of time and cost for large production plants. Various complex manufacturing products require complicated assembly process. Virtual reality can be used to simulate product, and the assembly mechanism can be carried out virtually for better understanding and evaluation. VR can add a new dimension to complex assembly. Workers with head-mounted virtual reality devices can easily be at their workstations and assemble components as shown in the virtual reality assembly procedure. Presently, Volvo has been using augmented reality systems in their assembly lines using Microsoft's HoloLens. There are many cases where the field technicians and workers need tech support and expert advice. This can be implemented through VR or AR systems which allow real-time solution of problems for the workers on field. VR and AR technologies can also be used in automobile manufacturing as a futuristic and revolutionary aspect. By integrating VR in automobile industries, large number of ideas can be evaluated and production rate will increase tenfold.
So that brings us to what is Internet of Things. The Internet of Things, also known as IoT, is relied upon to reform and change the way all organizations, governments, and buyers cooperate with the physical world. Internet of Things is defined as an open and far-reaching system of astute items that have the ability to auto-arrange, share data, information, and assets, responding and acting in face of circumstances and changes in the environment. So what are the applications of Internet of Things? Smart cities, smart home and buildings, smart transportation, and mobility. Many major cities were supported by smart projects, and by the IoT, cities can be improved in many levels, by improving infrastructures, enhancing public transportations, reducing traffic congestion, and keeping citizens safe, healthy, and more engaged in the community. Ever wanted your air conditioner to turn on before you return home in a hot sunny day? By the concept of the Internet of Things, the most important applications are smart lighting, smart environment, and media, air control, central heating, energy management, and security that can be all given a command with just a click from the user through their smartphones. A road condition monitoring and alert application is one of the most important IoT applications through which people knows whether a road is crowded, whether the road is under construction, or whether the road has a lot of potholes or other unfavorable conditions, following which they can make their decisions about which route to take in their journey. It is anticipated there will be a sum of $22.5 billion IoT gadgets in 2021, up from $6.6 billion in 2016. Following that, it is also predicted that there will be $4.8 trillion in total IoT speculation in between 2016 and 2021. So, how Internet of Things revolutionized manufacturing? Smart connected products that have the ability to carry on a process all by itself can be grouped into 4 key areas: monitoring, control, optimization, and autonomy, each building on the preceding one. For the first step, sensors and external data sources enable the comprehensive monitoring of the product's conditions, the external environment, the product's operation, and usage. Moving on to the next, software installed in the product enables control of product functions and personalization of user experience. For the third step, optimization allows systems to enhance product performance and allow predictive diagnosis, service, and repairs. Finally, autonomy allows autonomous product operation, self-coordination of operation with other products and systems, and autonomous product enhancement and personalization. An informed manufacturing plant contains 4 key elements of processes that speed up productivity and reduce expenses. These are informed products, informed people, informed processes, and informed infrastructure. Building up and interconnecting components in a system that communicates with cell phones, products, processes, individuals, and educated infrastructure will better oversee complexities and empower more effective manufacturing of goods. So, some companies that uses Internet of Things in manufacturing are BMW, HP, Toyota, Intel, and Ford. BMW knows the continuous status of all machines, creating all parts segments from all providers going into vehicles. Toyota decreases recalls by knowing precisely what machine created which segments of which vehicle. HP joins and combines network assessment and data visualization into its inventory chain management and screening. This has decreased their time for inventory chain management project by up to 50%. Intel and Ford use similar approaches to make an efficient manufacturing process.
So looking at all of these different types of technologies, the virtual reality, big data, and the Internet of Things, our group M1 decided to look into different predictions that we had. So 2 things that we came up with were artificial intelligence. So by saying artificial intelligence, we mean making a combined system that would be autonomous manufacturing. So it would use big data collected from the Internet of Things and create a virtual reality for an AI or a computer to analyze all of this information and eventually completely automate the system of manufacturing, so there has to be no human interaction whatsoever. We also see it as being easily accessible manufacturing, so allowing manufacturing to be done from a portable device such as a cell phone. So using all of this sensory information and big data, as well as creating the virtual reality on the phone, a user would be able to interface with the machines and be able to do so not from an industry computer, but from their cell phone instead, which would allow for an easy type of prototyping and designing for all levels of students, creators, inventors, and engineers. And with that, we'd like to thank you for listening, and that is our presentation.